Now we're going to look at a more extensive set covering problem. So in the previous example, in the hub problem, okay, given a hub in a city, which cities can it cover or already given in terms of distance or already given as input data. But what if we have to do a location decision as well as an assignment decision? That means a case where you have to decide whether you're going to locate a hub, and if you locate a hub, which cities you're going to assign to that hub. So that's the kind of example that we have here, but instead of airline and hub, here what we have is copier service centers, and we have potentially these cities that we have to cover. Now we want to locate service center in a selected number of cities. Okay. Now if you locate a service center in a given city, then you want to assign which cities that service center will cover in terms of serving them. And the criterion here is the distance. Okay. Now we are given how many service trips we have to make for each of the cities. Okay, that's given in the next page. And these are the distances from each of the cities to the other cities. So if we make an assignment, for example, if we assign Dallas to Boston, and if you have to make 100 trips, then 100 times that distance is the cost of making that assignment. Okay. And of course, to be able to make that assignment, there must be a service center located in Boston. So that's the problem. So let's look at the Excel file. So here are the distances between the cities, okay, and the number of annual trips that you have to make is given here. So this is given data. Okay. So to Boston there will be 885 service calls. In Chicago there will be annually 760 service calls, and so on. And these are the distances, and here is our location changing cells. So are we going to locate a service center in that particular city? Will you be locating a service center in Boston? Will you be locating a service center in Chicago? And so on. Now in addition to that, we also need to decide whether we will make that assignment. Okay, so here is if there is a service center in Boston, then which cities will be assigned to Boston? Okay, if Chicago has a service center, which cities will be assigned to Chicago? Okay, and we need to make sure that if a service center is not located in Boston, then none of the cities are assigned to Boston Service Center because there is no service center in Boston. So how do we do that? So well, with sum this way. So this tells us how many cities will be assigned to Boston. Okay. Okay. We can set up a logical capacity in this fashion. So how many cities are there in total? So that will be count. We will use count A because that's alphanumeric. Okay. Times 0.1. So that's the maximum that you can assign. So here, if this is 0, it will be 0. So number of cities that you can service will be equal to 0. But if this is 1, then it will become 11. So you can assign up to 11 cities to Boston. Okay, 11 being the count of how many cities there are. So let's put that back to 0. We copy that. Now we also want to make sure that the total assignments made is equal to 1, because you can assign a given city to more than one service center. So we want that to be equal to 1. That should be equal to 1. It's not less than or equal to, not greater than or equal to. They should be exactly equal to 1. Okay. Now, if an assignment is made, what is the distance? So this is distance for Boston to the service center to which Boston is assigned. So that will be some product of where Boston gets assigned with the distance here. So this will tell us what is the distance to the service center to which Boston is assigned. If we multiply these two and sum, that will give us the annual distance traveled. So total distance traveled is, you do a sum product of these two. Okay, number of trips with distance per trip, and we want to divide this by 1000 because that's what it wants. It wants in thousands of miles, and that's the objective function that we want to minimize. Let's give a name here. And number served by logical capacity. Okay, total assignments. We won't give a name for that. And we'll give a name for this as assignments made. We have to define this name. Assignments made. Okay, there is one more thing we have to do. We are allowed only 3 service centers, so we have to sum the number of service centers we will have, and that should be less than or equal to the maximum centers. Okay, let's give names here. And this is an input value, so let's, okay, so now we can do solver. Total distance must be minimized, and whether we're going to locate a service center or not, that is one set of changing cells, and then the assignments to be made. Then our constraints are the logical capacity constraint, so you can only assign if a service center is located, and each city must be assigned to exactly one service center. Number of service centers should be less than or equal to the maximum, and then the binary cells. That should be binary, and that should be binary as well. Simplex LP. Okay, now solve. Found the solution. So we're going to locate service centers Dallas, New York, and San Francisco, and these are the assignments that we will make, and this will be the total distance traveled in 1,000 miles. Now we can run a solver table by changing the maximum number of service centers that we are allowing, and then see what happens. Okay, solve a table, one-way table, and maximum centers allowed, and suppose we go from just one center all the way to 11 centers in increments of 1. Okay. And let's see, we want where the centers will be located. Okay. And total distance. Control click total distance. Click OK. Now it's going to take a little bit of time because it has to run through several iterations and each one requiring solving 0, 1 problem. So here it is. Okay, so if you locate 11 centers, that will be one service center for each city, then there is no travel at all, so 0 is the distance. And if you allow only one service center, so this is where the third one, and that is Dallas is where you locate the service center, and that will be the total distance.